Hello and thank you for a visit. In this video I would like to explore various different TIG welding techniques and see how weld and weave affects the finished welds, and also how the choice of different filler rods affect the welds that we get as well. So I have 3.2 mil, 2.4 mil and 1.6. The part that I'm going to weld is actually 6 mil flat bar and the 4 mil plate, all 316 stainless steel. So I won't need to use 3.2 mil simply because it is far too big of a wire for that sort of thicknesses, and especially considering that the configuration of the joints. So I'm going to be using, for the purpose of this video, I'm only going to be using 2.4 and 1.6. So to start with, I'm gonna go with 2.4 mil wire, and what I'm going to do, I'm gonna do freehand technique, free hanging, and I'm gonna be just using dubs, just as you see me doing this during this dry run. So the idea is to run for all this test, to run exactly the same amperage and just very different wire feed methods and various diameters of filler rods itself. So as you can see, I'm kind of forced to keep a torch at very steep angle, meaning very close to 90 degrees, simply because I knew right away that my amperage will be slightly too low. I'm going to be fairly cold, and that will be reflected in the welds as well. You'll be able to see that the weld is actually relatively cold. It's not going to be as creamy as what you can achieve considering the thicknesses that is getting welded. And well, that's pretty much what's happening. You're just keeping a relatively tight arc and dabbing, preferably with equal intervals, and you should get reasonable enough finish on the welds. Obviously, again, if you crank up your amperage, you'll be able to achieve slightly more creamier look to it than that, but overall it's still a decent looking weld. It should be totally acceptable on any project that you'll be able to do. It is worth to pay attention once we see the final weld, to pay attention to the colors in this weld, and what you will see that at the beginning of the weld and also at the very end of the weld will be more pinkish purplish kind of color, and on the middle of the weld it will be more of a yellowish straw sort of effect, and you will see every single individual dab as you seen it just now. But basically speaking, edges of the weld, it's pretty much corner pieces, so the heat cannot go away as efficiently as it can on the middle. You can really see it well in this shot. So the heat cannot dissipate into the main material, and that's the reason why temperature in those areas, the area that's a bit pinkish and the purplish, it's actually quite slightly higher than on the middle. So for this purpose, I'm going to use 1.6 mil rod, and I'm gonna lay it in. As you see, I'm bending rod a little bit down, and it's exactly how I'm gonna have it during the weld. The idea behind this, that I'm not going to be feeding in, I'm just going to be utilizing that rod as it is, and I'm going to set my tungsten to be in the corner when I put my torch 90 degrees into the corner. So the tungsten needs to be slightly more in. I never usually measure it or anything. I'm just allowing it to have a little bit more space underneath the tungsten for a bead, and this way I will be able to keep quite nice tight arc, and I will also be able to have space underneath my tungsten for a welding bead. So in this particular configuration, I get exactly the same amperage used as in the previous weld, and all I'm going to do, I'm gonna make I'm exaggerating just now to show you the type of weaving that's going to be in this weld, but in reality I'm just gonna make very small oscillations to basically run this bead. And as I mentioned, you can see it's fairly tight, but because our consumable is much more smaller, we're able to keep higher temperature of weld puddle, as it takes less energy to melt 1.6 millimeter welding rod in comparison to 2.4 millimeter. And as you can see, I'm still moving forward and I'm making very small oscillations with the torch, just walking. This is probably one of the easiest joints to do, corner joints, and it's also really open joint, so I can film it easily, because what I find during making these videos, that is actually increasing quite difficult to film a shot and position yourself in the position where you can actually be comfortable for a weld. But as you can see, it's fairly small ball at the end of a tungsten, which indicating for a very tight arc, and you can see that I'm having very small oscillations and very small steps, which should result in a relatively nice and creamy weld, simply because of how everything is run during this weld. Obviously my hand closing up a little bit, but you can still see the arc, and you can see the finished result in it. As I mentioned, that you can see that because everything is very fluid in the puddle, you end up with very smooth welding bead. So I'll just try to cover light a little bit with my hand, because it's quite difficult to film on stainless steel. It's very reflective. So if I put a little bit of a shadow, you see, yeah, you can just see how everything is. And because you have quite tight arc and relatively fast travel speed, you still get quite good color in your welding beads. You know, it's not overheated. I know it's quite difficult to overheat that sort of thickness, however, it's still possible. It's amazing what you can do when you apply yourself. So in this particular situation, we're going to use the same upper inch, same technique for doing the welding. The only difference is I'm going to be pushing in the welding rod into the puddle a little bit more active, and we'll see what sort of result that will come up. But yeah, so there will be a little bit of a push into the puddle. And there's the arc shot. So as you can see, the wire goes in, and there isn't that much of a difference in what I'm doing with my right hand with the torch. I'm still holding the relatively close puddle and moving forward, but because I'm introducing more wire, all of a sudden it starts feeling that puddle runs way cooler than on the previous run. And that's simply because your rod, your consumable, actually takes energy from your welding puddle in order to melt and become liquid and become your welding bead. So everything looks a little bit slower, and obviously the final result you will have is a weld going to be a bit more less flatter and a bit more rounded, convex, if that would be a bit more correct word to use. It's going to be a little bit more convex weld once we finish welding on this bead. Same again, you can still see the puddle is relatively solidified. I just stopped in the middle, and then you see what I was speaking about, that weld is a bit more filled up, the welding bead, in comparison to the previous run that we made. What you probably notice is, despite that it felt like a much colder weld, when we look at the colors between previous welding run and this welding bead, we'll see that previous one was a lot more straw-like color, and this one is a lot more bluish, pinkish, more leaning towards the blue side of the spectrum. And the blue side of the spectrum is a good indication that we actually we put much more heat into the weld, so we put much more heat into the material. And that's actually common thing. What happens is, when you slow down your travel speed, you start putting more heat into the welds. So this time I'm going to make my tungsten just slightly, so it's touching the corner, and I'm gonna lean my torch a little bit more, so it's not so much over 90 degrees, it's much more, and I'm gonna make really big steps, as what you can see, well, more of a medium size of steps, as what you can see along with the traveling. And I'm not gonna be moving the wire, not gonna be feeding it, I'm just gonna lay it out as what I had on the very first one. So this one, only difference is going to be I'm gonna be making much more clear and precise steps with my torch, with my ceramics, and you will see the difference in appearance of the welds. Yeah, you can see it's still slightly wider than what it used to be, and because I'm making more wider oscillations, and that should result in a different appearance in the final welding bead. Because I'm still using 1.6 wire, I'm still getting relatively a fluid puddle, and again, what you will see that because I'm moving relatively fast, we should also have it reflected in the welding color, in the colors of the welds. The only issue, what we also need to bear in mind, that this time I'll be coming over to the corner, so in the corner we may see some rise in the temperature again, because in the corner you don't have so much material that can dissipate that heat that you basically throwing in with every second that you weld in your material. Yeah, you can clearly visibly see that the welding puddle, it actually travels slightly wider at this stage. Every time I'm moving the torch, it just goes from one side to another. So with this, your welds should be slightly wider as well, and a bit more flatter, because you're kind of spreading that molten metal that you get out of your consumable. So, and that's pretty much the kind of appearance that you'll get, and you'll be able to clearly see steps in the as you are moving along with your torch. And as I mentioned, the closer you get to the corner, you can start to see changes in the colors as well. So when we started off, it's a bit more of a strawy color, yellowish color, and once we go to the corner, it's going a bit more of a blue hint in the color, and then turning slightly bit more into purple. What gives the colors to the weld? Again, I'm just trying to shadow it so you can actually see a little better, because it's super reflective on the stainless steel. What gives color hints in the welds is the oxide color. So here's another shot of those beads that we just produced, to give you a little idea how things are, how they look. Yeah, so you can see there is a quite difference between second run and first run on the 1.6 mil wire, and the third run looks slightly different. So it's amperage the same, all we're changing is different wire feed technique, and that's about it. So this time we're gonna use 2.4 mil wire instead of 1.6, and it's gonna be with the same amperage. And what we'll try to do, we'll probably just gonna go and recreate very similar movement what we had with our torch. Again, the length of the tungsten, how much it needs to stick out, quite often people give you numbers and so on, but the way I see it, you just need to measure up to the particular joint configuration that you're going to be welding, and basically put your tungsten into the corner and push it in a little bit more, or pull it out if you want your torch to be a little bit more in angle. Having the torch more leaning more and not having the 90-degree angle allows you to have very good control over welding puddle, because if you're on an angle, then if you're in the corner and you're at 90-degree angle, then you may be struggling simply because it's very difficult to control the heat that goes into one side or into another. But if you actually have it slightly leaning in the angle, then it's actually much easier to control. So I'm starting off from a corner, so it's kind of difficult to see on the video, and then I will just turn around and you should be able to see the arc shots. So again, I will try to keep relatively close arc, and I will try to keep just wire fed into it, and not pushing wire in, just trying to utilize the wire that's there. But you'll see instantly that it feels really cold. You can see that clearly when you look at the edges of a weld puddle and how welding bead is formed. It has very little fluidity. It's actually the edge is actually quite rugged. So, but you can still do this. You know, the weld's still gonna be relatively strong. It's just slightly colder, and it's not gonna have as nice appearance as what you've seen me on the very first run with 1.6 mil wire. Again, I'm maybe not 100% right to say that, because some people may like how things look in one way or another. No, there is it's all down to personal preferences, and but for myself, I would actually prefer it to have it slightly hotter and have it much more fluider puddle, so you can actually produce more creamier sort of weld than what you will end up with this particular example. If you have any questions or if you're struggling to see something, just write it down in the comments below, and I'll be able to address it in the next video, or I'll be able to answer it, answer your comment right away, and maybe you'll be able to get the answer that you're looking for. So when we look at it again, you can clearly see a bit more of a bluish tint in the color, and you can see that it's relatively cold weld, and again, simply because we had to spend so much time on the material trying to meld that wire in. What we actually have, we have put much more energy and much more heat into that particular weld, and that's the reason why it ended up of that color. So on this stage, what I'm going to do, I'm gonna make same as what you've seen me doing before, with 2.4 mil wire, and I'm gonna make just really big steps, and to let you see how that affects the appearance of the weld. Again, when you started off for a couple of moments, your welding puddle isn't as hot, simply because the material takes it up, and once you heat up material, and then you can weld with a constant speed. And again it's a little bit on the cold side. You can see it, at least for my preferences. Again, maybe for somebody else it's totally fine, but I would prefer it to have slightly hotter, and this way I would have much more fluidity in the puddle, but it's still okay on the end of the day. Obviously it's quite natural when you moving from side to side, you kind of spread in that molten metal as you go along, and again it should produce nice and kind of flat-ish type of weld with this type of oscillations. As you can see, the oscillations, that movement on the torch is slightly bigger than what we had in the very first run that we done with 2.4 mil wire, and it's kind of similar to our second run that we did on 1.6 mil wire. The only difference is this time we didn't have to forcefully feed into this wire, because it's actually relatively cold as it is. So if we would start feeding the wire even more aggressively, we would be having much more convex weld, and it would be just a bit more cold. way colder than, again, as I said, that I would prefer. Yeah, the colors still remain kind of a bluish, and the reason why the ends are kind of yellowish is simply because at the end, after we stopped our weld, we actually end up with the gas still flowing over it, so it had a chance to cool underneath the coverage of the gas. So this time I'm just using the same 2.4 mil wire, and all I'm going to do, I'm just going to make really wide swipes, really wide oscillations, running the same amperage again. The only difference is really wide oscillations, and as you making the side movements, you making the forward movements as well, forward steps, and it kind of, even now you can see that you'll be able to see each step separated and segregated on a welding bead. Again, some people like it, some people don't. To me, it doesn't make much of a difference. I'm not really use that type of welding. In most of my welding, I usually use just freehanding methods. Sometimes when it's a box sections, you have nice corners like this one, I'll just use some thinner type of consumables, and I'll try to go as quick as possible and make it as creamy as possible. It's just my personal preference. Again, it doesn't mean it's right or wrong. It just something that works for me. And if you guys been watching all of these videos that I've been producing, quite often I would say that it's not the right way or wrong way, it's just the way that works for me. So if you have a better way of doing it, I would be interested to hear that or to learn from you, because every day is a school day. So that's pretty much what we have. And because we're actually spreading our molten metal across wider surface area, it reflects in our colors as well. Our colors are much more yellowish and much closer to that cleaner look, simply because the temperature that we spread is actually going on a wider surface area. So this time what I have a roller which is 8 mil wall, and there is a side plates that are 8 mil wall as well, and in the middle there is a shaft which is 50 mil 2 inches. So what happens there is, on this sort of thicknesses, you can really crank up your amperage, and you can use heavier rods like 2.4 mil rods, but you can weld it with a similar kind of effect as what you've seen on the very first run was 1.6 mil wire, simply because now you have material that can take much more heat, and you can crank up your amperage and you can run it much more hotter as well. So the puddle is a lot more fluid, and you can make it much more creamier weld. And again, as I mentioned, it's just my personal preference on this one. Obviously, if you have a chance, you can roll things, and you can work in a really comfortable position. Or if you have not so critical application like this particular roller, you can just use opportunity and weld a little bit more difficult position and have a chance to practice a little better. So basically this is how the joint set up, and if you run it from bottom, you'll be able to walk all the way up during the joint. And again, this happens to be a really good joint to actually show what's going on, because normally if you're trying to weld something, you're really closing everything, you're covering up all details, but in this particular configuration it actually worked out really nice, and you'll be able to see that the white arc, and you can see molten puddle, and you see that you can move that molten puddle from side to side, which results in nice flat weld. And you know that you penetrate into material because you can actually see that everything around is moving and everything is liquid form, and you have really good control because the puddle isn't too liquid and the puddle isn't too cold at the same time. It's just perfect. It moves behind your tungsten really nicely. and it produced nice and controllable results. So this time, just this type of a joint, and I'm just trying to make a dry run to see how I can affect. Obviously I'll need to move hand away, otherwise I'll be closing on the, and you won't be able to see anything. So again, the comfort of your welding, it's very, very important. If you have a comfortable position, you'll be able to achieve really good result, and if you're put yourself out in discomfort zone, then you're going to be struggling, simply because it doesn't feel natural to you. If you've been doing something for years in one way, and then all of a sudden you have to move in a way that is out of your comfort zone, then it's just natural that you will be able to see, you'll be able to see it in the weld, you'll see it reflected in what you're doing. So now you see, instead of having wire parallel to the welding bead, I'm actually shifting it out in order at 90 degrees in order to actually have it visible to you. So you'll probably be able to see it in the welds once we finish, because your wire feed rate changes, and with the wire feed rate, as we already seen it in previous videos, it will affect how your welding bead will look. And you can see it, yeah, when I'm just covering with the shadow, you can see much more creamier start and a little bit more reflected the surface. So on this side, I'm just gonna show you a couple of samples of aluminium welds, and you can see the beads are separate far in between. That's what happens if you allow quite big distance between your dubs. You can get effect like this. And again, my preference a little bit more tighter beads, just personal preference. So that sort of a bead, and very kind of similar what you have on here. You run it hot and you run it tight, and the weld ends up relatively flat. So, and it's pretty much, again, if you make it really hot, you can even sometimes run it so smooth you cannot distinguish between different beads on the welds, and I quite like that as well. But again, everybody to their own as far as likeness of, and you know, what people like and how things appear and so on. But hopefully this video was interesting and informative to you, and if you like it, just put thumbs up, and if you want to see more stuff like this, different videos about welding and other things, just subscribe to the channel.